We're talking about N channel JFETs. Okay, so like I said before, you can think of them as a wire, it's a piece of silicon actually, a conductor of silicon with electrons coming in on the source and going out on the drain to the load, and we're just going to affect that channel with the gate. And we have to make it negative to make it work, okay? If it's in plus, then it's on, okay? It's operating. But as I make it more negative, I begin to pinch it off right here at the channel, okay? The more negative I make it, the more it pinches off. The one that we're looking at today pinches off at minus 25 volts, completely pinches off. So if I want it to completely go off, I have to take it to minus 25 volts. Now you might say, well, my LED's out. Yeah, but your LED will light at what? 2 milliamp or 2.7 volt at about 20 milliamp. Okay? So you still got to take it down another, it's at minus 9, you got to take it down another, well, another 9, well, 12 volts or something like that. Okay? More than that even. Okay? All right, so the gate will pinch it off. Now, here's what it looks like. Here's what the circuit looks like. What we did was we hooked it up with the drain to a LED. This is R2. 1K ohm. That's our load. And we wanted it to light up. Drain, source to ground. That's where we get our electrons for the flow. Where does the current flow? Current flows like this. We can call it ID, current flow, from source to drain. Now, we don't have it connected right to that flat bar. No diodes in there, notice. Are there any diodes in the device? No. It doesn't use NPN junctions with depletion layers. It uses a solid piece of silicon right here that just goes right on through here, and then it pinches it right here. So we use an arrow to show that it can pinch it down. Now, we didn't have, it doesn't take a positive voltage to turn it off. It takes a negative voltage, so we had to use an isolated supply. So we used a 9-volt battery, and we turned it around. We put the positive to ground, and we put the negative to the base resistor, 10K ohm, which actually is the gate. We call it the gate, and it turns the device off at 9 volts. Not quite. It's not pinched off at 9 volts. Can't see the LED, but it's not pinched off at 9 volts. Okay, still flowing some current. It has to go to minus 25 volts to pinch off. And how did we know that? We looked in the data sheet which I gave you. This particular device is a 2N5458, and for those of you online, you'll need to look that data sheet up. 2N5458. Look up the data sheet and it will give you the parameters. The gate parameter is the one that you're interested in, minus 25 volts. If you breadboard it, this is the way you breadboard it out to test it out. Okay? If you have a different JFET, just look up the parameters and plug it in, and it will work similar to what this does. Okay? All JFETs work like this. Okay? So it's a junction FET, but it does not have any diodes in it. It's just a simple piece of silicon, N silicon, it's an N JFET, with a gate that pinches it off.